You ever been in the middle of a conversation with an AI and it completely forgets something you told it like 2 minutes ago? Yeah, it's super frustrating and it points to a huge problem in AI. But what if we could build agents that have a perfect memory? Well, today we are diving into Mastra AI, a framework that has a pretty revolutionary answer to that exact question.
So why does this even happen? You got to think of an AI's short-term memory, its context window, as a really small notepad. As your conversation goes on, every single message, every tool output, it all gets scribbled onto that notepad. And, well, eventually you run out of space. Important stuff gets pushed off the page, and the AI starts to seem, dumb. And this isn't just a random annoyance. It has a name: context rot. It's what happens when the agent gets so completely bogged down in old, irrelevant details that it just loses the plot. Its memory gets cluttered, which means its performance gets slower, its answers get less accurate, and let's be honest, it gets way more expensive to run. Okay, so how do you solve a problem like that? Mastra's whole approach is kind of beautiful in its simplicity. They decided to make AI memory work a lot more like our own. This quote from the Mastra blog just nails it. Think about it, right? You don't remember every single word of a conversation you had yesterday. Your brain just doesn't work that way. We observe what's important, and later on, we reflect on those observations, storing the key takeaways. And that's the exact human-like principle that Mastra's observational memory is built on. So, how does this human-inspired system actually work under the hood? Let's pop the hood and take a look at the architecture. It's basically a three-tier system. Think of it like a funnel. At the top, you have the raw message history, the messy moment-to-moment conversation. As that gets too big, it's distilled down into the second tier, observations. These are like concise little notes about what happened. And finally, when you have a whole bunch of those notes, they get condensed even further into reflections, which become the agent's core long-term memory. And this whole process, it happens automatically in the background. You've got these two little agents, the observer and the reflector, that are kind of like the AI's subconscious. Once the chat history hits a certain size, the observer steps in and compresses it into observations. Then, when the observations pile up, the reflector condenses them into deep memories. And the best part? The main agent you're talking to is never interrupted. It just keeps working. Okay, so that all sounds great in theory, but what about the results? This is where Mastra's approach really shines. Let's start with compression. For agents that are using a lot of tools, like, say, browsing the web or reading a giant file, the context can get absolutely bloated with useless noise. Observational memory can get up to 40 times compression. That's huge. It takes all that junk and turns it into clean, useful observations. And what does all that incredible compression get you? How about state-of-the-art accuracy? On the long mem-eval benchmark, which is designed specifically to test an AI's long-term memory, Mastra hits a staggering 94.87% accuracy. And you can see that dominance right here on this chart. When you compare it to other top memory systems like Supermemory and Oracle, it's not even close. This isn't just a small step forward. Mastra's observational memory is in a totally different league. It is, right now, the best performing system in the world on this benchmark. Okay, so benchmarks are great, but the real question is, how does this amazing performance translate into the real world? What does it mean for the apps we're actually trying to build? Let's take a super practical example, a browser agent. A single web page can dump over 50,000 tokens of just raw HTML code into the agent's memory. It's a disaster. But with observational memory, that entire mess gets distilled down to just a few hundred useful tokens. Something like, okay, the user found the login button. The agent stays on task instead of drowning in code. And this isn't some science project. This tech is already being battle-tested in the real world. I'm talking in major companies. Replit uses it to power their AI coding assistant. Big names like PayPal, SoftBank, and Marsh McLennan are all building their own long-running, reliable agents using the Mastra framework. Now, you might be thinking this all sounds really complex, but probably the best part is how incredibly easy Mastra has made this for developers to actually use. One of the absolute cleverest features is something they call asynchronous buffering. It's on by default, and it means those little background memory agents do all their cleanup work before the context window is totally full. So when it's actually time to compress everything, it happens instantly. The user never ever feels a lag or a pause. It is completely seamless. And for all you developers watching, getting started is about as simple as it gets. You just run one command in your terminal. It's a batteries-included framework built on TypeScript and designed to get you from a quick prototype to a production-ready agent fast. So all of this brings us to the most exciting question of all.
By finally solving this problem of context rot, Master's observational memory isn't just making today's agents a little better. It's unlocking the door to entirely new kinds of applications, agents that can be true long-term partners, remembering things not just for minutes, but for days, weeks, or across entire projects. So the question isn't just about what this technology can do, it's about what will you build with it.